Hello everyone, my name is Eric. I'm going to be solving a related rates problem for my calculus class. Okay, the problem is that the hands of a clock are 3 meters and 2.5 meters in length. How fast is the distance between the tips of the hands changing at 9 o'clock? So that's what I've drawn here. So the minute hand is 3 meters, hour hand is 2.5 meters. We'll call this A, B, and the unknown side as C. So the fundamental relationship that relates this length to this angle would be the law of cosines. So we have c squared equals a squared plus b squared minus 2ab cosine theta. A and b are constant, the lengths of the hands do not change, so we can go ahead and plug those in to make the derivative a little simpler to take. So we get c squared equals 2.5 squared plus 3 squared minus 2 by 2.5 by 3 by cosine theta. 2.5 squared plus 9, this is 15.25, and so we get, what do we get there? 6 times 2.5 becomes 15, minus 15 cosine theta. Oops. Okay, so we want to take the derivative of this now. So we get 2c by dc dt equals, that would be 0. Negative 15 by negative sine, so it just becomes 15 sine theta by d theta dt. At 9 o'clock, we can figure out the length of c with just the normal Pythagorean theorem. So we get square root of 2.5 squared plus 3 squared equals, what do we get with that? About 3.9 meters. And we know that the minute hand has a rate of change that is 2 pi per hour. The hour hand is 2 pi every 12 hours. So to figure out the rate of change in theta, the angle between them, it would be the rate of change in the angle in the minute hand minus the rate of change in the angle of the hour hand. So we get 2 pi per hour minus, let's just make that pi over 6. So this would be 12 over 6, and we get 11 pi over 6. So the rate and change in the angle between the hands is going to be 11 pi every 6 hours. We know c is 3.9 meters. We know the rate of change in theta from this here, so we just need to rearrange this to figure out the rate and change in the length of c. So we end up with 15 sine theta d theta dt divided by 2c, that equals dc dt. At 9 o'clock, theta is 90 degrees, so sine is 1. So we get 15 times the rate of change in theta, which is 11 pi every 6 hours. And I guess that 15 would be meters. Oops. And that would be divided by 2 times the length of c at 9, which is 3.9 meters. And doing a little calculator work. We end up with let's just round that to 1, I guess. 11.1, and that would be meters per hour. I think. I better check that. Hold on a second. So yeah, it would be in meters per hour. So the rate of change in the distance between the tips of the hands is 11.1 meters per hour. Hope that was helpful. I know I kind of stumbled through it, but good luck everyone with your related rates of change problems.